If you've solved subsets 1, the way to make this problem very similar is to essentially follow the same backtracking process, but to prevent duplicate subsets when we have potentially duplicate values in our input nums array, we want to make sure that if we make the choice to exclude a number, we want to exclude all numbers of that value. The easiest way to do this is by first sorting the input array. This way we can have a pointer to skip all the values of the same numerical value, and we can be sure we have done that as the array is sorted. And then I'm just going to create the resulting list. And a helper method is really helpful here to help with the backtracking. And we're going to pass in our res, and we're going to create a new array list, which is going to be the current list at any point of time. And then at the end, we're going to return res. So in writing the helper method, we can first consider the base case. So the base case is essentially when the index is greater than or equal to the length of nums. At this point, we know we have reached the end of our decision tree. At each number, we have either decided to include or exclude all values, all numbers of that value. So when index is equal to the length of nums, we are done with our decision tree. So we can add a copy of the current list to our resulting array, and then we want to return here to avoid indexing out of bounds. And similar to subsets 1 and pretty much all other backtracking problems, we want to add like a clone of the current list instead of the actual list because of reference semantics. Now, if we're still making decisions, we can first consider this case in which we do not include current index value. So in this situation, we're going to want to recurse immediately, except with one caveat. Because we do not want any duplicate subsets, and we know that we may have duplicate values, we want to make sure that we increment our index to a point where the next value, and when we call subsets to the index, is going to point at a value that is not equivalent to the current value. And we can just do this by incrementing the index to the right because our array is sorted. And so we can do it like so. First we do a check to see that this is within bounds, and then we just see like if nums of index is equal to nums of index plus 1, we want to increment index. So now when we call our method again and we recurse, what we can do is we can do index plus 1 here. So this would be the closest next number that is not equivalent to the current value at our current index. And then, yeah, we're going to have our res and cur. And then now we consider a situation where we include the current index. And we can see we kind of like potentially have changed index when we consider the case where we do not include the current value. So what you want to do here is create like a hard copy of what index is. So down here, when we want to include the value at the current index, what we can do is first in our current list, we're going to append the value at I, which is our current index, and then we're going to call this method again. We're going to recurse, and then we're going to have nums I plus 1 because we're now going to consider the next value, whether we're going to include or exclude that, our result and our current list. At the very end, we're going to successfully do the backtracking by removing the very last element of cur. So let's see if this works. Hmm. Okay, cool. Sorry about the hiccups in the middle, but yeah, glad this worked.